On behalf of NOARK Electric, we're excited to walk you through how advanced transformer solutions are helping shape the future of the electrical grid. Today's session will cover key product fundamentals, real-world applications, and how we can support you with fast, reliable solutions that are especially helpful in today's high-demand, fast-moving energy market. NOARK Electric is part of the Chint Group, a leader in electrical equipment and energy solutions. At NOARK, we focus on delivering low, medium, and high voltage solutions across North America and Europe, supporting OEMs, contractors, and distributors. What sets us apart is the combination of global manufacturing strength with localized North American support, allowing us to respond quickly to project needs while maintaining high quality and competitive pricing. Company strengths, value proposition. Our value proposition is built around four key pillars. First, in-house research and development. All products are developed, tested, and certified to meet strict international standards. Secondly, world-class manufacturing, backed by ISO certified facilities and advanced production capabilities. Third, strong North American distribution channels with facilities in Texas and Ontario, Canada, to ensure reliable delivery. And finally, excellent value, high-quality products backed by a 5-year limited warranty, helping customers reduce risk while staying competitive. Product certification. As a global manufacturer, Chint and NOARK place a strong emphasis on third-party testing and certification. Our transformers are tested by internationally recognized laboratories and comply with major standards, including IEC, ANSI, IEEE, UL, and CSA. With over 20 years of experience in transformer design and manufacturing, we've built a robust system that ensures our products meet regional requirements across global markets. This gives our customers confidence in both performance and compliance, regardless of application. We have world-class manufacturing abilities. To support growing demand, we've made significant investment in advanced manufacturing technologies and automation. As you can see in the slide picture here, our facilities are equipped with modern production systems, from precision core cutting and coil winding to automated welding and high voltage testing. This allows us to deliver consistent quality, high production capacity, and shorter lead times, which are critical in industries like renewable energy, data center buildouts, and industrial projects where speed and reliability are key. Ultimately, this manufacturing strength translates into faster delivery and dependable performance for our customers. Before we dive in technically, let's take a quick look at today's agenda. We'll start with product basics, where we'll cover key transformer fundamentals and core features. Next, we'll move into application scenarios, highlighting where these solutions are typically deployed across utility, industrial, renewable energy, and data center environments. From there, we'll walk through standard solutions and quick quotation capabilities, showing how we support fast turnaround times for your projects. We'll also review UL certification details, ensuring alignment with North American standards and requirements. And finally, we'll wrap up with case studies and real-world examples, demonstrating how NOARK and Chint have successfully delivered on speed, performance, and reliability. So let's get started. Kunmi Odonku our technical product manager, will walk you through the key aspects of our transformers.
Thank you, Bill. Good
I'm going to
afternoon
stop
and good
sharing.
morning, everyone. Once again, my name is Kumi Odunoku, and I'm here to take you through the technical presentation on this training. So just give me a moment, and I'll share my screen, and we can go from there. Okay, great. I'm just gonna go straight into transformer basics. But before I do that, I want to start by giving us sort of like an overview of the power system architecture. So it's a simple image that just gives you an idea of what we are talking about when we're talking about power transformers, where they are situated along the power system architecture. So if you look at this power system architecture, it starts from the generating station here. Use the laser. Yeah, so it starts from the generating station here, and then it goes through the transmission lines, and you have substation transformers before it gets to the consumer. Now, for the consumer, there are different kinds of consumers. You can see some medium voltage consumers. You have the primary consumer. You also have secondary consumer, which will be your residential and commercial or building and stuff like that. But this is a simplified diagram, and a lot of things go into this, before from when the power is generated till the final end customer, a lot of components, a lot of equipment. But because we're talking about transformers today, we wanted to just highlight, where you have those transformers and, why we need to have them. So you can see from here, when the power is generated, it goes through a step-up transformer, and you might want to know why is that the case, and that's because you need efficiency. So when you generate the power, it goes through a step-up transformer. And then I will explain a little bit more later why we do that. And then when it's about to get to the end customer, then it goes through a substation with a step-down transformer. Now, what's a transformer? Transformer is just a static electrical device that transfers power from one circuit to another. So from our elementary physics, we know that power is equals to voltage times the current. Now, so when the power that you are getting from the generating station gets to the transformer, that part that it gets to first is the primary. And then when it leaves the transformer, that side is known as the secondary. But as you can see here, the transformer, what it does is it transfers energy from one circuit to another one. So the power remains the same. So for example, if the generating station is generating 2000 megawatt, right? It's that same amount of power that is going to lead the transformer. Now, the reason why we go through a step-up transformer in this case is because we want to, because there is an inverse relationship between current and voltage. So when you have the current, when you have the voltage going up, the current is coming down. And when you have the and so it's so that's how the step-up transformer works. So you have the voltage very high on the primary side. Sorry, you have the voltage on the primary side very low, the current is more. Then when you step it up, you're increasing the voltage, and then the current is coming down. And that helps you with an efficient transmission line, because power loss across the transmission line can be significant, especially if, and that's always the case, where the generating station is, hundreds of thousands of kilometers away from the end customer. So you want to reduce as much losses, because from my elementary physics, power loss is the square of current multiplied by the resistance along the line. So if you're having lots of current along that transmission line, you're going to have so much power loss, and that defeats the purpose of your power being generated. So what we do with the step-up transformer is we're reducing that current to the barest minimum so that the overall loss along the line is reduced significantly. The other thing you're doing is that you're also reducing the capex, because the cross sectional the cost of a cable is directly proportional to the cross sectional area. So if you're having a cable that is larger in terms of the cross section, you're going to be spending more, right? So efficiency, and also in terms of overall capex, that's why we do that. And so, like I said before, a transformer, whether it's a step down or a step up transformer, it's just transferring energy from one circuit to the other. In the case of a step down transformer, what we are doing is that we are reducing the number of turns on the secondary, so that the voltage that is induced is reduced significantly, so that and then the current in the inverse relationship goes up. If it's a step-up transformer, you are basically you are trying to increase the voltage induced, and then the current is reduced, so that you can have efficiency along the transmission line. So that's the power system architecture in a nutshell. So for our power transformers, we do have different ranges up to 1000 kV, 1200 1200 MVA for the three-phase, and then the single-phase 750 MVA. For the natural ester, which is the medium of cooling, so we do have two types: the mineral oil cooling and also the natural ester oil cooling. We can do up to 750 kV here and up to 1000 MVA. So our transformers, they have high short circuit withstand, low losses, which results in energy savings. So basically, when we talk about the transformer efficiency, is directly related to the no load loss. So the amount of losses that is generated when the transformer is powered on without being connected to a load. That loss is directly proportional to the efficiency of that transformer. And for us, we try to reduce that no load loss as much as possible in order for you to have more efficiency. We also, like I said, we have two cooling. We do have the mineral oil and natural ester. And the abbreviation for these are the ONAN and the ONAF. I do have another slide where I talk a little bit more about this. So I will talk more about the why we have these letters and what they actually mean when it comes to, or in terms of the cooling medium for the transformer. All of our transformers are type tested, so we've got the third-party testing on them, and we can customize this transformers depending on the customer use or need. So again, in terms of our capability, like Bill said earlier on, Chint is our parent company. For our transformer factory, we do have two plants. You have the one in Shanghai and also at Wuhan, and combined together more than 75,000 square meters of manufacturing space. And we've been doing this for over 20 years, shipping to 120 countries worldwide. So again, we can customize to whatever the need of the customer is. And our point of contact, we will be happy to help you in terms of, getting out the specs and making sure that you have all the customization that customer will need. We'll talk more about that later on in terms of how we do the quotations and, the road to market for us and the sales cycles that is involved when it comes to the transformer. The other type of transformer I wanted to, we actually want to talk about in this training is the pad mount transformer, and it's really our main focus. We do have pad mount transformers, rated up to 35 kV, and also in terms of the capacity, up to 10 MVA. But in terms of the UL certification that we have, it goes up to 5 MVA. Now, for the pad mount transformer, it's an interesting one because these are distribution transformers, but that have been sort of customized for customer use. So for a pad mount transformer, it's fully integrated, both the HV and the LV compartment, and all the other components like the tap changers, the load break switch. All of these are, integrated into one single unit, and that's what you have here. It's in terms of space saving, it's very fantastic because the volume is usually 1/3 of a prefabricated substation. If you've ever seen a prefab substation, it's usually, sometimes it could be in like a 20-foot container, depending on the size of the transformer, and then it's going to have the transformer inside. It's going to have the MV switch gear, the low voltage compartment, and usually it's very large, right? But the pad mount is so what's the word? It's been fully integrated such that the volume is reduced. You also reduce in terms of the size and the cost as well. So it's an interesting product. Some of the other features that you have here are the dead front. So we want it to be completely safe for any personnel that comes in front. I will explain a little bit later on what we mean by the dead front and the other things I mentioned here, which are the load break switch, the tap changes, and all that stuff. So to start with, just to show you the key parts in the pad mount transformer. So on my left here, you have the radiator, which is what you use in cooling the fans, right? You have the backup limiting fuse just on the side of the transformer. And here, this is an open view. So you can see here, you have the HV bushings and you have the LV bushings on the other side of it, the load break switch, and you have the plug-in fuse, the tap switch, and all of this, components, they are there for specific reasons. So I'm going to just walk you through briefly what each of this means. So the bushing, firstly, what are the bushings for? Why do we need them? So basically, bushings are, they are used they are isolators that are used in order to bring power into the transformer, and their use is not limited to the transformer alone. You use them also on the transmission line in substations and stuff like that. But basically, when you're bringing power into this pad mount transformer, for example, that the power has a rated voltage, so the potential is there. But remember that this pad mount transformer is grounded to the earth, so it's at zero potential. So you're trying to bring something, with higher potential, maybe 12 kV or even 15 kV into a device that is at zero potential. So you want to make sure that you don't have any kind of short circuiting around that. So this bushing is what we use to achieve that, right? So the bushing is such that it completely isolate the conductors from the metal casing of the pad mount transformer. So that's what we use them for. You have the high voltage bushing and you have the low voltage bushing as well, which is on the LV side. Then we have the load break switch, which I'll talk about later on. But basically, why we say it's a load break switch is because you can use it while the transformer is on load, while the transformer is actually supplying power to a load. So that's why we call it a load break switch. Then you also have here the tap switch. In this case, it's an off-circuit tap switch. So why do we need that in a transformer? That's because and I just try to do a simple example here. Whenever you're trying to, bring power into a transformer, the power comes in at a primary voltage. In this case, we're talking about a step-down transformer. And then on the secondary side, what you expect is that the voltage is going to be reduced to the level that you need. And for example, if you have a 2,500 kVA transformer, and the primary is 13,800 volt or 13.8 kilovolts. We expect to have 480 volts on the secondary side. Remember what I said about the relationship. So if the voltage is reducing on the secondary side, then the current is going up, right? So that's how you know. Now, the thing is that sometimes, because of seasonal usage, because of peak hour usage, this voltage that is expected at the primary can change. It can go up, it can go down. And because we want to have that same 480 volt, or want to have as close as possible 480 volts on the secondary side, then we use this. That's why we need a tap changer. Basically, a tap changer is a series of windings in a transformer that allows you to select. So this is how it works. You can have a 5-position tap changer. So in this case, this is a 5-position. So it has the first position, which is the 100%, right? It has that 13.8 kV. Then it has plus 2.5%, and that gives you 13,455 volts. And then plus again, sorry, I'm saying the other way around, minus 2.5%, and then minus 5%. So the tap changes every 2.5%. So plus or minus 2.5% on this side and on this side. So if ever, so for example, when you have peak hour usage, the voltage can drop. And when the voltage drop, for example, if the voltage drop to around 3,400, then you're not going to get 480 volts at the secondary side. You probably get a 468 volts. And again, we don't want that, right? We want to have as close as possible to 480 volts on that secondary side. So when that happens, then you need a tap changer. That tap changer allows you to be able to change what you have on the primary side so that you can still get the required 480 volts on the secondary side. The other type of tap changes that we have are the 7 position. So we have 5 position, we have 7 position. All these we use. For this particular pad mount transformer, it's an off-circuit tap changer. We also have what we call the on-load tap changer. So the on-load simply means that, well, let me say that the off-circuit tap changer, what it means is that if ever there is a fluctuation in the voltage and you need to change the tap, they have to de-energize the transformer first. Then they go right here and do the tap change for the transformer. So you have to de-energize first. But for the on-load tap changer, you don't need to do that. You can actually go and do the tap change while the transformer is still energized. So that's the difference. We also have what you call the auto tap changer. So in the case of an auto tap changer, you don't even need to physically go there. It's automatic. It self-regulates itself. When the voltage drops, it compensates. And when the voltage increases also, it will compensate, just to ensure that you're constantly getting the voltage you need on the secondary side. So that's why we need a tap changer. Again, for our transformers, we have other things that I wanted to share with you guys. So the cooling class, like I said before, this diagram explains why we need a cooling in the transformer. So we have the internal cooling that has to do with the cooling medium, which is either mineral oil or natural ester. And on the external side, we use air for the cooling, and that's what is represented here. So when you see an ONAF transformer, what he's saying is that the transformer is using oil, natural oil, that's to cool the transformer, and then the natural air also on the external part to cool the transformer. If you see a KNAF, it means it's a natural ester. and air also. Sometimes you can have forced air or you can have forced oil. In that case, we are not just relying on natural convection. We are using some sort of pump or fan to increase circulation to cool the transformer, whether through the cooling medium, which could be oil or it could be natural air. So we're using some sort of equipment to force the air around the transformer or to force the oil around the winders in order to cool the transformer. The other thing that you would see in the transformer is the configuration, which is also called the vector group. So we say we can do whether it's a delta or a wide combination. So we can do any of them, basically. A delta just means that all of these ends, all the windings are connected together this way. And then for a Y, it means that the coils, at one end of the coils are all connected to one point, which will become the neutral. So we can do any of this configuration depending on what the customer wants for their application. The other part that I should mention also, we keep talking about the bushing configuration. We say we have the loop type and the feed type. Now, this talks about the type of supply that you will get in the area where you want to install the pad mount transformer. So if you have a radial distribution, this picture explains what that means. So from your MV sectionalizer, that's from the utility or wherever you're getting the supply from, you're going to have a single, conductor, right? And then from there, you have tapped off to the individual pad mount transformer like this. So in this case, you have four pad mount transformer using a radial distribution. So you can see it's coming from a single source, and then it's tapping off to each of those pad mount transformer. So you can have that. And typically this kind of distribution system, you find it more in remote locations, right? Where maybe reliability is not really a big issue. So you don't have a redundant system here compared to the loop distribution. In the loop type, you can see that you have two supply kind of right in this picture. So it's the same pad mount transformer, four of them in a loop distribution. So it goes from one transformer to the next one, to the next one, to the next one, and then back to the supply, so that you have a loop distribution. So again, this is more common in your city, around the cities, in built up areas, residential areas, because what this does is that it gives you reliability, because you can actually have a second supply, because sometimes you could have faults happening along for example, in the radial distribution. If you have a fault along this line, it means that everybody that is being serviced by this line is out of power. But in the case of a loop distribution, if you have a fault along this line, you can simply feed again from this end to all the customers without them losing availability. So that's the importance of the loop type of distribution. And that's what we explained here with this diagram, because you can go from this bushing, it goes into the transformer itself, and then it leaves again through this bushing, you're going to the next transformer, and then again, you go from here to the next one. So that's what we call the loop distribution. So depending on what the customer wants, we can provide that, whether it's radial or loop distribution. And how do we, like I was saying before, these are the bushings that you have here. This will be the incoming and this is the outgoing, right? So it goes in from here it goes into the transformer winding. At the same time, is leaving the transformer through this other bushing. So if you see this is the loop type. If you see the radial type, it's just going to have three sets of bushing on this side. You don't have anything here because it's just directly taking that, and it's not leaving to go to another loop distribution. So how do we achieve the how do we use this loop distribution? So it uses what we call the load break switch. You have the 2 position and the 4 position. This is like a section of it. So you can see this part is what you see at the front, and all of this part is right inside the transformer. So it's a simple switch that allows us to switch. If we want the transformer to be so these are the different positions here. So for example, if we want the transformer to be in the loop configuration, so then the power comes from A, and then it leaves through B, at the same time is feeding the transformer coil, right? So that's how, so that is one position. If you decide to switch to another position where A is off, so you're only feeding the transformer from B and it's going to the coil at the same time. So this again, you can do maybe in the case where one side is faulty, you want to feed through another side. That's what you do here. And then this fourth position here is when everything is off. So, right, so A is off. Sorry, this position here is when A and B feed through, but you don't have any power to the transformer. So if you have, for example, an off circuit tap changer, and you wanted to change the position, then you have to put the load break switch at this position here, so that you have completely de-energized the transformer. Then you can go ahead and change the tap position, because there is already a voltage fluctuation, and you want to compensate for that so that you still get the right voltage at the secondary side. So that's how we use the load break switches. With together with the other components that you have in the transformer. So yeah, this is just
a quick reminder, Kunmi, that you just have 5 minutes more. Thank you.
So this is just again, this is our spec sheet that tells you a lot more about what we are doing. I mean, in terms of the spec for the transformer. I won't go into a lot of details here, but again, this is it summarizes what our spec sheet looks like for a standard transformer. And in terms of the product naming, this slide is just explaining what we mean, when we say, you need a 25 kVA transformer, and on the primary side, you need 13.8 kV, and on the secondary, you need 480 volts. So this basically just shows you what each of those numbering stands for. I won't go into a lot of details there, because in our catalog, you have all this information there, and you can avail yourself to them later on. So for the UL certificate, this is that's what I have on the screen right now, and the various voltage options that you can get. Again, these are there for us to read later on, and you can digest them. But this is our UL certificate, which is also available if you want to take a look at it. To summarize, the pad mount transformer. What we are giving in terms of value proposition is that, smaller integrated volume, low noise in terms of the operation. We have the UL certificate, and we have the very short delivery time. In fact, about 55 days from the time when your drawing is approved. So that's a very good lead time for manufacturing. So for application scenarios, I talked about them. We use them in residential areas, and you probably have seen them around your homes as well. Industrial complexes, industrial zones, data centers. You can have this power transformer in a variety of locations. Just to round off my presentation, I wanted to show you what it looks like when you send a request to us to quote the pad mount transformer. So if it's a standard transformer, you can do it in under 3 working days. If it's a custom one where you're having some customization, we can do it in 6 working days. For manufacturing, like I said before, we have a very short what do you call it now? Manufacturing lead time, 55 days, 12 weeks. and then we will ship within 6 to 8 weeks. So again, it's important to highlight the fact that the freight is almost like 20% of the cost. So to optimize and to make it more cost efficient, we say that it makes sense to ship not just one unit. You probably, for a 20-foot container, you want to ship 3 small rating or 2 large rating. If it's a 40-foot, you want to ship 4 small ratings or 3 large rating. That way you can, be more efficient in terms of the shipping cost, and you can save some dollar there. So, for example, on March the 16th, we received this RFQ, and by March the 18th, we already got the offer from the factory. So again, this is because we've standardized a lot the pad mount transformer, and so it's easy for us to make the quote. But if you need a custom one as well, it just takes us just a few more extra days for us to be able to deliver in terms of the quotation and all the submitter packages that come alongside with it. And so that brings me to the end of my presentation. If you have questions, you can just note them down. Once we go through these case studies, 2 of them, then we can open the room for questions. Thank you. So I'd like to hand over to Alice right now to go through the case study.
Hello, can you hear me? Yeah. Yeah, Alice. See some cool friends online. Nice to meet you here. Okay. I'm relatively new actually for this T&D business as well. About 2 years experience. I feel very lucky actually being awarded with 45 units of pad mounted transformers by one of the top 5 hyperscalers, and how I made it without not much experience though. So firstly, just let me get started with my story. Firstly, I received the RFQ back to 2025 October. So actually, I was requested to make a quote the same day. And what happened then, after I did make it the same day, but I was awarded the order like after within 3 days, like October 15. And with the cutting, with the drawings, we offer the drawing approved within 4 days as well. And production actually we made like the pad mounted transformer production we made like 1 month, about 1 month. And actually, you may think this whole thing is quite easy. Actually, it's not, because firstly, the timeline. We made the quotation like the same day. Actually, it's not 48 hours. But how we made it, because we have a standard. Because we think that pad mounted transformer, I don't know how much you know about pad mounted transformer, is like something standard commodity, like circuit breakers. So they have kind of a standard SKU numbers or something with the ratings. You just pick up the primary voltage and capacity or copper or aluminum, then you get the price. Okay, about that's the quotation thing. Next one is accelerated delivery date. So you know that China is a big factory thing, and our workers can speed it up. They can also work like 24/7 for the customers. That's our advantage for sure, right? And next one is about because lead time not only including the production, but also including the ocean shipping too, right? So actually we found, because the pad mounted can be fit into a 40 HQ containers, so we find a very fast vessel. So the ocean shipping can be 12 days only from China to the port of Long Beach. And yeah, also because like you said, that's how we made the customer approve our drawing so quickly, because we made the cut sheet at the standard thing. When the customer they have any customized thing, we can just make some adjustments based on the standard drawing or cutting or cut sheet. That's what we did. Yeah. What I learned from this order, trying to share something I think that's might be useful to you guys. Not sure your background, maybe from my point of view. Firstly, pad mounted is not that complicated. It's more like a commodity, like standard commodity, like breakers, like mini breakers. So we also developed quick quote app already, and maybe you can just get the cost within 1 day or maybe even shorter. After this, you can make a quote to the customer very quickly. Okay. And the other thing is, because and then for this by this way that the quotation is no longer a bottleneck in the future, but also it will be a weapon to to get the order, right? Because you can make a quotation much quicker. And the other thing is just one thing, let you know that pad mounted transformer is like a standard commodity. It's not like a cutting edge technology, right? So remember that when you do a sales price, they're not. I just remind you that not much. Don't mark up too much, especially do not mark up too much when it comes to, especially when it comes to many channels in tune already, right? So we have very good pricing, but because it's not that new technology, right? Just to remember the marking up thing. The other thing is about the key to success. You can feel that how I get the order because the speed, the production, the delivery. So I can feel that the Change Electric and NOARK can offer the best lead time for sure, with huge, massive capacity of the factory. Please, if you have any pad mounted RFQ in the future, feel free to contact us. We offer the RFQ and best lead time ever. Thank you a lot. Yeah. That's about it. I will hand, please, I think it's the next one is Bill Ryder is going to share the power transformer case study. Thank you a lot. Thank you all. Bill?
Yes. Thank you, Alice. Thank you. Yeah, so I'm going to talk about my A1A renewable energy project. This was a group of solar and wind projects involving 8 high voltage transformers. It came with a very aggressive delivery timeline and a highly assertive supply agreement. We first received the RFQ in June of last year of 2025. From there, the project evolved over several months. There were multiple specification changes, site revisions, and ongoing discussions. By early September, the supply contract was approved, and then by early October, we were officially awarded the purchase order. Yay. So production and shipment then stretched over a long horizon from early this year, 2026, through September 2028, with multiple delivery dates across all 8 sites and the 8 transformers. So you can see this wasn't a quick transactional sale. It was a complex multi-year engagement. So this project came with several challenges. First, the contract itself. So a lot of large renewable energy projects are financed by private equity companies. So there's use debt financing, and there's complicated contracts or complex contracts. There was a strict supply agreement requirements, including a bank performance bond and about 8 to 9 weeks of negotiation just to get things started. Secondly, we had accelerated delivery expectations. The customer needed 3 of the 8 sites to move up delivery dates significantly, which meant compressing both production and logistic timelines. Thirdly, we had logistics complexity. We had to provide accurate delivered duty paid pricing, DDP pricing, factoring in ocean freight and inland transportation, while costs were fluctuating, like Alice mentioned earlier. And finally, we had scope changes. High voltage circuit breakers were added later, and those came with their own challenging lead times. So last year, 2025, was a very interesting year. There were constant fluctuations in raw materials, tariffs, and freight. So it really kept us on our toes. We responded with a focus on speed, alignment, and visibility. Firstly, we committed to same-day responses to every customer inquiry. I was told that my competitor normally took 5 days to respond, and that came directly from the customer. We provided the customer with full access to technical resources, 24/7. Just send it over, and we took care of it. We involved senior management on both sides very early to open up communication channels, remove bottlenecks, and find out who truly makes the final buying decision. With high voltage transformers, their costs are anywhere from $3 million to $8 million per unit. So you most always have a C-level person in the company involved with a signature or at least a VP. So this is a big ticket item, and everyone in the company, usually, senior management, gets involved. We also invited the customer to visit the factory to build trust and transparency. So lessons learned. One of the biggest lessons learned is the importance of having a champion on the customer side, someone who understands your value and helps guide the project internally with their strategic team members, engineering, finance, senior management, like I mentioned earlier. Also, understanding the customer's urgency and internal pressures gives you a real strategic edge. I suggest you learn everything you possibly can about the customer's projects to tailor the perfect solution and win their business. Also, internally for the salesperson, this kind of project reinforces the need for a customer playbook, capturing what worked, what didn't, and how to replicate success with future deals. That was my input on the A1A renewable energy project. I appreciate you guys taking the time